moving into the part which is how to solve equations. Okay? You may have done some solving of equations before, but you need to learn to do it the right way now. So, I mean, this whole unit is just solving equations. We're going to start with, as they always do in Algebra 1 textbooks, one step, and then two steps, and then multi-steps, and then variables on both sides of the equation. And then we're going to do proportions and percentages. And finally, we do what's called literal equations. And literal equations have more than one variable, and you've got to solve for one of the variables, it's always the hardest thing for us to do. I'm saying that the quiz dates are TBD, to be determined, because I imagine we'll have several quizzes, but I'm not sure which date it'll be on. The test, I think, will be on the 25th and 26th of October. Okay, so what is an equation? What is it that makes something an equation? It's got an equal sign in it, right? So like when we were doing, as we've done most of up till now, we're dealing with expressions, right? An expression is something like 2x plus 1, right? That's not an equation because there's no equal sign. If I write 0 equals 2x plus 1, that's an equation. And if there's only one variable in the equation, then you can solve it. So what does it mean to solve an equation? What does it mean to solve an equation? No, not to plug in something you already have. Yeah.
To put a number in F and
well, it's not. Yeah, go ahead.
You add the like terms or whatever you have to do for like terms.
Okay, so the answer is you're going to try to isolate the variable on one side of the equal sign, and then whatever's left on the other side of the equal sign, that's the answer. And you know, the first equation there, you can see we're going to do that problem eventually in this class. The other three are from another class. That's Algebra 2 Trig. But you know, it means the same thing no matter what. You know, there's a variable, there's only one variable and one equation. You should be able to isolate it. So what we do now is just try to like learn the basic steps for solving an equation. And some of which, you know, you might have had before, but we really need to practice using the right steps when we do this stuff. Okay, luckily we're not going to have sines and cosines and logarithms and things like that. But when you solve those, you got to do these same things that we're doing now. I mean, this is just the starting point. So it's going to be important you show work. I mean, especially in what we do today, which is solving one-step equations. Most of this stuff you could do in your head probably with mental math. But I need to see, like, what's the step you're taking to isolate the variable? And it'll get more complicated, you know, as each day we get into this. So, I mean, this is an example of a one-step equation because we're only going to have to do one thing to isolate the variable. So what is the variable? X, right? And so is X alone on its side of the equal sign? No. That's why we say we need to isolate it. So what's with X that we need to move so that X can be alone on that side? The plus 7, right? So how would we get rid of a plus 7? You would subtract 7, right? But this is the fundamental thing about algebra. If I do it to one side, right, minus 7, let me undo that, blue. If I do it to one side, I got to do it to both sides. So minus 7, draw a bar, X equals. Okay, now we're going to add them up. What's 7 plus negative 7? Or 7 minus 7? It's 0, right? That's why we did it. What property is it that says that 7 plus negative 7 is 0? Additive inverse, right? Additive inverse equals, what's 4 plus negative 7? And at this point, you're going to have calculators now, okay? So don't get some of this simple math wrong. 4 plus negative 7, get it right, negative 3. Okay, what's X plus 0? X. What property is it that says that if you add 0, you get the same thing? Additive identity, right? So the first one was additive inverse, and this is additive identity, and x equals -3. So when we subtract the same thing from both sides, that's the block you should have copied for the X credit homework, right? That's a subtraction property of equality that basically says if you subtract the same thing from both sides, you still have an equation. You know, it's still balanced between what's on the left and what's on the right, right? Because that's what an equation is. Yeah, man. No. No, but I just thought I'd throw it in for this one. But you should show the -7 from both sides. Because believe me, we make lots of mistakes with this all the time. I'll have a kid on that step that puts +7 instead. How is a +7 going to cancel a +7? It's not, right? So it's important to like show your work and what is it you're trying to do. So here's your first U try. Try to do the same thing with that. Probably going to take you about 15 seconds. I mean, believe me, a lot of you have issues with basic arithmetic. Use the calculator. Get it right. You know what I mean? Don't make a silly mistake on something that actually you had a tool right there. So what did you have to do on this one? Subtract 7 from both sides, right? So that is x equals 10 minus 7 is 3. Now, what you might, because a couple of you might said, what's solve? Solve to you kind of meant plug something in, right? Well, that's actually part of the SOLs. Part of the SOLs is that you should be able to verify whether something is an answer. And when you've gotten equations to solve in the past on a test in multiple choice format, I mean, a lot of times, what are you going to do? You're just going to plug it in and see which one works. You know, back substitution. And by all means, on the SOLs, we'll do whatever we have to get it right. So if you want to back substitute, that's okay. But on our tests, I'm not giving you multiple choice. You really have to solve it. Okay, so that's subtraction property of equality. Okay, how about this one? What am I going to have to do to both sides here?
Add 12.
Add 12 to both sides. Right? X equals 3 plus 12. 15. Okay, what property do you think that is? It's one of the ones we copied from last night. When you add the same thing to both sides? Addition property of equality. You know, that's the thing that allows you to do, as long as you do it to both sides, you're good. Okay, try this one. Did you both parts of the test? Both? Calculator? Okay. What'd you do to both sides? Add 11 to both sides. So x equals, what's -5 plus 11? 6, right? So I know this is pretty basic, and you know, most of you could just like visually, you could see what's the answer, right? That's mental math, when you could like in one step just see it. But we want to be showing our steps. Okay, which property of equality do you think we have to use here? You're going to divide. So what property would that be? Division property of equality. Okay. I mean, these are part of the properties, like commutative, associative, identity, inverse, and then all these properties of equality. So what am I going to divide? So again, you say, what's x with? And what's the operation between it? So what's going on between -6 and x? It's multiplication. So the inverse operation of multiplication is division, so you divide both sides. So divide -6. Remember, whatever you do to one side, you do to the other. Again, I've seen times when we have to do essentially that operation in a more complicated problem, and it turns into a divide on the left and a subtract on the right. So that's not, you got to do the same thing on both sides. Okay, so the negatives cancel, or the -6's cancel. And what's 48 divided by -6? -8, right? No mistakes because we got calculators. So there's your U try for the division property of equality. What did you have to do to isolate the y? Divide by -5, right? So y wasn't alone, it was with a -5, and the operation between them was multiplication. So what operation do we need to do? Division. Divide -5. Divide -5. And y equals +13, right? Remember, negatives divided by negative is a positive. Just like negative times a negative is a positive, division works the same way. So, okay, which operation do you think we're going to have to do here? It's x is not alone. It's being divided by 4. So what's the inverse operation of division? Multiplication. So we need to multiply by 4. So we're going to multiply 4 and times 4, right? And with a 4 in the numerator and a 4 in the denominator, they cancel. So that isolates the x, and 5 times 4 is 20. Don't worry, there'll be easy homework, won't it? Okay, try this one. Figure out what you need to do to isolate the c. Do it to both sides. What did you have to do? Multiply by 7, right? Times 7. And so the 7's cancel. C equals, what's 6 times 7? 42. Okay, now that would make you think we're done, right? We did add, subtract, multiply, and divide. But we're not done. Okay, what do? When you're multiplying by a fraction, you're actually both multiplying by 2 and dividing by 7 at the same time. So, Kaylee? Multiply by the reciprocal, right? What we're supposed to learn how to do here is, if you have a fraction that's multiplying times the variable, multiply by the reciprocal. And what's another word for the reciprocal? Another term for? Multiplicative inverse. Multiplicative inverse is the reciprocal, right? So if you've got a fraction multiplying, multiply by the flip, right? 7 over 2. Right, multiply by that times 7 over 2. Right, now the 7's cancel, the 2's cancel, all that's left is x. And now, what's 4 times 7 halves? Well, it's 14 halves, right? If you multiply it straight across, you would get 28 halves. You're right. I was thinking something different, which is 14. But remember, you can cancel the denominator of 2 goes into 4 twice. 2 times 7 is 14. You were right. I was wrong. I was getting ahead of myself. I mean, in a way, you're going to say, well, x is being multiplied by 2/7. Why wouldn't I divide by 2/7? Well, you could, right? If you divide by 2/7, right? 2/7 divided by 2/7. I mean, what's anything divided by itself? It's just 1. So that would definitely work. It would cancel that. But then on this side, we would have 4 divided by 2/7. Okay, now this goes back to the last unit. How do you divide by a fraction? You flip and multiply, right? So in the end, you're going to get 4 times 7/2, which is what you get if you just don't divide by that fraction, multiply by the reciprocal. So it's kind of like saves a step to just multiply by the reciprocal. But you're not wrong to say divide by 2/7. It's just now you got to figure out how to divide by a fraction. Okay. So try that one. So what are you going to multiply this one by? 6/5, right? 6/5. So I'm going to write it here. 6/5 times 5/6 times W equals 6/5 times 10. Right? So all of this cancels. That's why we did it. And then 6/5 times 10 is? Did everybody get 12? Okay, I want you to show you something on the calculator now. Since you're going to have the calculator, I want you to know how to do everything that it does, right? If you bring up your calculator, I'm going to bring up my emulator up here so you can see what I'm doing. Assuming that it comes on. Sometimes I need to... Why is that not going? There it is. Is it somewhere off the screen or something like that? Just a second. Let me do this. Switch to tablet mode. Okay. And let's see whether we see it this way. Okay, there it is. Yeah, it's a computer and a tablet. I mean, that's why I can write on it, you know. So, in any case, okay, now go to the main screen. Second, quit, clear. Okay, so let's say we want to do 6 times 10? No, 6/5, right? Here's how you can enter fractions as fractions. You don't have to say like 6/5. You're going to go alpha, which is the green button, and y equals 1. And see, now you get a fraction to enter, so you don't have to worry about parentheses around the numerator, parentheses around the denominator. That'll save you some mistakes. Okay, so now I'm going to put in 6. I'll arrow down to the denominator, 6/5. Then I'll right arrow to the right. Now I'll put times 10. So see, you can enter it just like it looks on your page, and you'll get it right every time. Yeah. Not to get the fraction format, I don't think. Unless they've added it there.
Oh, mine looks good. Mine I do 6/5 enter, and I hit now twice. It runs 39
Okay. So anyways, just remember, if you want to enter something as a fraction, alpha, y equals 1. Okay, let me get out of tablet mode. See if I'll be able to keep this. Yes. Okay. So try that one. What do you think you have to multiply by in this one? You can multiply by 4/3? What do you have to multiply by? -4/3, right? So if you want to make that just positive 1m, you got to multiply by a negative, because a negative times a negative is a positive. Okay, so -4/3 times -3/4 m equals -4/3 times 9. Right? The negative cancels negative. The 4's cancel. The 3's cancel. M equals, what did you say? Say it again. M equals -12. Did everybody get -12?
Yes. Yeah.
Does anybody need help putting it in the calculator if that's the way you're doing it?
No.
Alpha, y equals 1. Okay. So one more. Is it one more? 16, 17. Why do I have 2? So basically, in Algebra 1, all we're concerned with is isolating the variable on one side of the equal sign by doing operations to both sides. And those are all those properties of equalities that we would have copied from the first 2 pages. Right? Now, we're supposed to do real-world stuff too. So in 2004 Olympics, Sean Crawford won the 200-meter dash. His time was 19.79 seconds. I don't think that's the record, but it's pretty close to the record. Okay?
Oh, never mind.
Okay, find his speed. Find his speed if we know that the distance he traveled equals the speed. Quiet, please. Speed times time, right? So what am I going to substitute for the distance in this equation? The distance is 200, right? The speed we don't know. How long did it take him to run it? 19.79. So how do you solve that equation for the speed? I mean, think of it like this. If speed is the variable is s, let's say, then let me write it like this. 200 equals 19.79 times s. How do I solve for s? It's division property of equality. Divide both sides by 19.79. Okay, so that cancels. What is 200 divided by 19.79?
10.10.
Okay, 10.10. Okay, what do you think the units of that is? Well, it's speed, right? So meters per second. Right? Meters per second. Now, does meters per second mean anything to any of us?
Yeah.
No, not really, right? What's the unit of speed that you're used to hearing about? Miles per hour, right? So let's convert this to miles per hour, right? First, when it comes to meters, how many centimeters in a meter?
100.
Okay, so I can say 100 centimeters per 1 meter. Okay, and I'm going to tell you that there's 2.54 centimeters in 1 inch. Okay, how many inches in a foot? 12, so I'm going to go 12, 1 foot per 12 inches. And then how many feet in a mile? Okay, say it again.
5,180.
So 1 mile, clear. I gotta erase that. 1 mile is 5,280 feet. Okay. Now that's going to change, right? The meters cancels meters, centimeters cancels centimeters, inches cancels inches, feet cancel feet. Our units are now in the numerator. We've got miles. Now we need the denominator to be hours. So right now we got seconds in the denominator. How many seconds in a minute? So we would say there's 60 seconds in 1 minute. And how many minutes in an hour? 60 minutes in 1 hour. Again, now our seconds here will cancel the seconds here. The minutes cancel minutes. And in the denominator, we got hours. So we need to do all of this math. We need to multiply 10.1 times 100 divided by 2.54 divided by 12 divided by 5,280 times 60 times 60. And then you'll have the speed in miles per hour. 22.59 miles per hour. Does that sound reasonable? I mean, when you run that fast? I mean, I kind of remember when people are running their 100 meters that they get up in the upper 20s, like close to 30 miles per hour. So this, going the 200 is probably reasonable. It's good. So that's real world. There you go. So the homework is that. And you need to show work. If I get just a bunch of answers but no work, then half credit.